Hi students, let's look at this question here, which is taken from the year 2017 paper 2 question 10 of the H2 Math A-level paper question. So this question is on normal distribution. So a small component for a machine is made for two metal spheres joined by a shorter metal bar. The masses in grams of the sphere have this distribution. So this case here, I'm just gonna let the mass, let X be the mass of a sphere in grams. Okay, so this will be X. This is normally distributed by 20 and it has a variance of 0.5 square. I think that's pretty okay. Then find probably that the mass of a randomly selected sphere is more than 20.2 grams. So the first one, the required probability should be quite probability, it will just be px bigger than 20.2 grams. So I think this shouldn't be a problem there. What we do is just key in calculator and we just put 20.2 and then just for lower bound and the upper bound we just put 10 to the power of 99, right? So this case here, I'm just gonna distribution and go to normal CDF. The lower boundary, what we have is 20.2 and upper bound is 10 to the power of 99. And mu will be 20. And of course, this is sigma square. So just take note that the sigma is 0.5 and the variance, the standard deviation is 0.5. And key in calculator, that will be 0.34457. So this is 0.34457. Then that will be 0.345 3SF. Right, so that's how we do the first part. So for the second part, in order to protect them from rusting, the spheres are given a coating which increases the mass of a sphere by 10%. Find the probability of a mass of coated sphere. So you have to know that let's say the mass will just be y. The coated sphere will be increased by 10%. So it will just be x1 plus 0.1 of x1. Okay, so increased by, this is actually the same sphere they're looking at. So this should be 1.1 instead of x1 plus 0.1 x2. Okay, so it's because it's the what do you call it, the this case here, because it's actually the same sphere, so it's 1 plus 0.1 x1, not x1 plus 0.1 x2. Okay, so it's the same concept there. Just be mindful. So this case here, I'm going to just let y be the mass of a coated sphere in grams. Okay, so that's about it. So once we're done, it'll be y, the normal distribution. So to find the expectation of y, this will just be ey will just be 1.1 ex, and we know that variance y will be 1.1 square variance x. Alright, so this case here, y 20, this will be 1.1 times 20, and the other 1.1 square times 0.5 square, and that's pretty okay. Then what we need is the required probability. Probability would then be y between 21.5 y and 22.45 grams. Okay, so that's about it. So key in calculator should be able to get an answer there. I'm gonna just key this in. So normal distribution, normal CDF, and we're gonna put 1.1 times 20, and the other one, what we get is, oh sorry, there's 1.1 times 20. Then this over here, just remember to root it. So root of 1.1 square times 0.5 square. There you go. The lower bound, what will be is 21.5, and the upper bound is 22.45. Alright, so that's about it. So just key in calculator. That will be 0.611722. So this will be 0.611722. Then that will be 0.612. Okay, so that's about it. So let's look at part 3. The masses of the metal bars are normally distributed with 60% of them having mass greater than 12.2. So I'm going to just, because we're looking at the mass, so I'm going to let M be the mass of, let M be the mass of a metal bar, okay, in grams. So I'm going to put everything in grams. Then what we're going to do is just going to write down what is given to us. Okay, so this case here, M will be N mu and sigma square. I'm going to let it be mu and sigma square. And we're told that it's given that the mass PM are normally such 60% of them have greater than 12.2 grams. This is 60%. And the other given is that 25 of them have a mass less than 12 grams. So mass less than 12 grams will be 25%. So this is obviously using standardization. Shouldn't be a problem there. So this case here, what we're going to do is actually just standardize this Z. Then this is 12.2 minus mu over sigma. And this is 0.6. This is PZ. Less than 12 minus mu over sigma as well. Standardize it. And this is 0.25. You're going to use calculator. This will be inverse norm then. Inverse norm. So of course you have a left and right. So this is 0.6. This is pointing towards the right side. So just take note of that. This over here, this will be right. Okay, this is right. This is left side, pointing towards the left of the curve there. So this is 12 from GC. We know that 12.2 minus mu sigma will be equals to negative 0.253347. Okay, then for the other side, 25%. So inverse norm. Inverse norm here, that will give us 0.25. So 0.25, and this will pointing to the left. So just make sure that your tail is the left tail. And this is negative 0.674489. So this is 12 minus mu over sigma negative 0.674489. Okay, great. So from here, we just need to solve this simultaneous equation here, and we should be able to get the answer then, okay? So the mu and the sigma, find the mean and standard deviation of the masses of the metal bar. So this case here will be, if we arrange this, this will be mu minus 0.253347 sigma, which is 12.2, this is 1. Then the other one will be mu minus 0.674489 sigma equals to 12. This is 1 and 2. So solving using GC, you will get the answer there. So solving 1 and 2. From GC, you have mu. This is simultaneous, so I think simultaneous is not just use GC, okay? Solve it, then this will be 12.32. 12.320, and your sigma, what we have is 0.4748. So this case, mu will just be 12.3 grams, and sigma 0.475 grams. These are all 3 SF. Okay, so that's how we do this part here proficiently. So the mean of the metal bar, this is the mean Standard deviation is this. Okay. Yeah, that's how we do this questioning proficiently. So let's look at part 4. Probably the total mass of a component is actually consisting of 2 randomly chosen coated spheres and 1 randomly chosen bar. Is more than k gram is 0.75. Find k, setting the parameter of any distribution you use. Okay, so the component, a small component for machine, we were told that we take 2 spheres. 1 sphere here, so 1 sphere. And after which you use another sphere, and there's a metal bar in between. I'm not sure. You can just draw it out like that. Okay, so this is a component. Okay, so this is coated and coated here. This is the metal bar. That is what they're trying to say. Okay, so there's a metal bar inside, metal bar in between. So it's made from 2 metal sphere joined by a short metal bar. So the probably that the total mass of a component. So total mass, let total mass, a mass of component. Okay, so let total mass, let T be the total mass. That is, let T be the total mass of the component. So this T here will obviously be, this would be 1.1x1, right? The mass of a sphere, coated sphere. So we 1.1x1. Then you have got 1.1x2 because this is another sphere here. Okay, so you just need to know that because there are two independent spheres, so it's x1 and x2. So this is coated will be 1.1 and this will be 1.1x2. Okay, be mindful of that. They are independent. So that will be your actually y1 and y2 if you want to. So this case here, the last one will be the metal bar, which is m. Right, this is the total mass. And we're told that consider of 2 randomly chosen coated sphere and randomly chosen bar is more than k gram is, so given that PT more than k grams is actually 0.75. So we need to find 7. Okay, we need to find k. Find k single parameters on distribution. Okay, great. So this case here is pretty okay, I think. So this will be T equals to, actually this is y1, right? We use y, right? We use as a y for the mass of a coated. So this is y1 plus y2 plus m. Okay, so T exponent, this will be expectation of the total mass will just be EY plus EY, which is 2EY. Maybe I just put 2EY. 2EY plus EM. Okay, that's 1. So EY here, what we have was EY is actually just what 1.1 times 20 plus EM, which would we found EM just now, which is mu 12.320. So use more than 3 SF. Alright, so that will be 12.320. There you go, just key in calculator, should be a good answer. Then later I'll write down. Then the variance of T will obviously be 2 variance Y plus variance M. Okay, so this is just finding all the parameters that is required of us, and try and solve this part here. So here, what we get is actually 2 variance Y. Variance Y will be here 11. Keep saying here 11.1 square times 0.5 square. Okay, so 0.5 square there. There's a y 0.5 square. Then after which you have variance m. Variance m will be this over here, sigma, which is 0.74 474,899 square. Okay, so just key this in. We will have our total mass here, the normal distribution here. So just gonna key in calculator. This over here would be 56.32. So the meaning to say this is 56 56.32. Then after which the variance here will be 0.830529. This is 0.830529. Okay, so this is it. We need to find the K. So I think this is pretty okay. We just need to basically use standardization, or we can just use standardization. We can use inverse norm if you want. Inverse norm will be good. Here will be just T. So TK is here. This is our T. So this is 0.75. Normally distributed of 56.32, 6.32, and this is 0.830529. Okay, so all you can do is just inverse norm. So from GCA, K is equals to, just key in inverse norm, 0.75 on the right. So this over here will be inverse norm, 0.75, and what we need is actually 56.32, and this will be square root of 0.830529, and I need this to be on the right side. So we 55.705. 55.705. This will be 55.7. Alright. We can probably put it as K. There you go. So that's how you do this questioning proficiently. If you have any questions or comments at all, please let us know and I'll see you in the next question.